Hello, everyone. I guess we are almost time to start. So thank you for coming to our session, Kubernetes and etcd, common pitfalls and how to avoid them. And this especially for those large-scale consumers who might be coming across all these issues. So before we start, I want to talk about the code of conduct, which basically boils down to being nice to everyone. And a little about ourselves. I'm Arka Saha. I work at Broadcom as a software engineer, and I'm a contributor in etcd.
Hi, everyone. I'm Nabarun. I also work at Broadcom. I work on specific Kubernetes bits for the Kubernetes distribution team at Broadcom. I also try to maintain a few areas of Kubernetes. Henry, also from the etcd community, was supposed to join the talk, but he could not make it to this KubeCon. So I joined Arka in the talk in explaining a few bits of how to avoid the common pitfalls. So I'll give to Arka to go through a journey of like what are the common issues that one might run into.
Thanks. So let's see why etcd is so important in the Kubernetes space. So as we all know, etcd is the heart of Kubernetes, and as this image has been repeated multiple times over multiple talks, it is the very small but very important building block of Kubernetes itself. And here we will be seeing what happens when etcd breaks. So etcd is dead, Kubernetes is broken, user is going crazy as what's going on with the cluster. So let's see what are the errors that can cause. So when etcd stops working, the cluster becomes read-only. Any kind of requests for creating or updating won't go through. And any kind of API requests will also error out in that scenario. And even if it is able to get through, the data might not be updated across all the members of the etcd, which will cause inconsistency in the data. So to avoid this problem, Kubernetes and etcd has a very well laid out contract, which basically says that Kubernetes depends a lot on etcd's underlying core logic and functions. And this document mainly reinforces on that and makes the documentation and testing of both the projects more robust. So let's look at the common pitfalls that one might run into in running and managing their Kubernetes clusters. So say you have VMs to which you have attached 100 or 200 GB of disks, and you want to run your etcd clusters on that. And you think that you have 200 GB of space, but that is not quite it. Because the default etcd size when you run an etcd cluster is 2 GB. And you can increase it through quota byte backend bytes. And it is recommended that you increase it to 8 GB, beyond which the compaction might take more time and which might make etcd cluster run slowly and with higher latency. So the error that you might get while running into the space issue is that MVCC database space exceeded issue. And that can be managed through compaction to start with. So you can have auto compaction, and you can show the revision up to which the auto compaction should work, or you can compact on demand. And next comes the defragmentation, which is an expensive thing to do because it needs to be done per member of the etcd cluster, and it has to be done one by one. And it can cause some kind of network delays or latency. The next is the upgrade issues. And we know that etcd 3.6 got released after almost 4 years, and everybody excited to upgrade to it. But you might run into a few problems while doing that, depending on from which version you are coming from. So one of those common errors is too many learner member in the cluster. Let's look at why you would run into such a problem. So etcd 3.5 source of truth is v2 data store. Although it has v3, but the source of truth lies with the v2. And in 3.6, we have removed the v2 data store, and there's only v3, which is the source of truth for 3.6. Now, when you want to upgrade from 3.5 to 3.6, what can happen is that one member which has been upgraded to 3.6, and it is a learner, and it has caught up with all the data from the leader, and is up for a promotion to a follower, this data, this request, will be persisted in v3 since it's in 3.6. On the other hand, when a leader has synced its data with another follower, and the member election happens, it has the request to be demoted to a follower. And this data will be persisted in v2 data store, which means there is a data inconsistency. And due to this promotion and demotion, there are like two learners at this point, which brings us to this problem of too many learners. And etcd, by rule, allows only one learner at a time. And this issue has been there from 3.1 to 3.5.1 to 3.5.19, and it has been fixed in 3.5.20 and above. And there is another version of this issue that you might run into, depending on how you are upgrading and from which version you are upgrading. So if you are upgrading from a 3.5 patch to another 3.5 patch, you are good. You won't run into that issue. If you are upgrading from 3.5.20, where we fix this issue, to 3.6, you won't run into this issue. But if you are doing a rolling upgrade, say from 3.5.1 to 19, and then you upgrade it to a patch of 3.5.20 to 23, what can happen is one of the old snapshots which had that error of 3.5.1 and 19 might be copied over to the new member of 3.5.20, and this can cause the same learner issue in 3.6 any version. So in this rolling upgrade scenario, this issue can happen again. So this has been fixed in 3.5.24 and the above versions. The next issue is the slow network issue. So in case your cluster is having a huge network latency and the network slowness is too much, you will be seeing errors like rejected connection on client endpoint or connection error. And this basically means that the etcd members are not able to communicate within themselves, or the API server is not able to communicate with the etcd. So to identify these errors, we need to have a comprehensive tooling which will tell us from the start, from the point we run a cluster, that whether anything is going wrong with etcd. And to do that, we do have a few commands, something like a health check command, which can tell us that whether the cluster is running healthy or it is not healthy. But there are many other things that we want to check, many other metrics that we would want to check, which is difficult to get right away. So that's where etcd diagnostic comes in. So etcd diagnostic is basically a very powerful tooling where we have combined all the health checks, all the other metrics that we would want to check for a healthy cluster. And we have compiled it into a binary of etcd diagnosis where you can use it on an online or an offline cluster. And a simple one would be just generating an overall report of the cluster. So you just do etcd diagnosis report, you give the endpoints, and your etcd diagnostic report JSON is created. And the JSON would look something like this, where it checks for the members, it checks for the endpoints with the EP status check, it checks for the serializability, it checks the linearizability, and it also checks the metrics. And how to avoid them, Nabarun will take over.
OK. So I would want to do a quick quiz. How many of you are running Kubernetes at scale in production? Let's say 100 node clusters. OK, quite a few. 1,000 node clusters. 5,000. Beyond what Kubernetes supports? OK, we have a few hands that I know of. How many of you are running etcd but not for Kubernetes? OK, nice. Good to see the hands that people are using etcd beyond Kubernetes use cases. Nice. OK, so the problems that we have seen, mostly you will see them when the cluster is degraded, or when you are in conditions which probably might be beyond your control, or maybe some misconfiguration. One of the common misconceptions which Arka rightly mentioned is that it does not mean that whatever sized VMs you create, etcd will run up to that size. So you need to carefully choose what space quota you are giving for etcd. There are ramifications for that as well. If you give a high space quota, you will run up with long compaction and defrag cycles. So you need to know what data you are going to store in your environment. So an analysis of upper bounds and lower bounds is necessary to decide what space quota you should put. What you should also put in is monitoring of the space quota metrics. So etcd exposes two specific metrics, one which specifies what is the actual size in use of the database, and another metric is the total size in use of the database. The total size does include all of the empty memory that is being used by the database as well. So for example, let's say when you start creating a lot of objects and a lot of churn happens, you update objects. What would happen is your total size in use as well as total size will increase. But at some point, if you run compaction, you will see that size in use will decrease, or if you run delete operations, your size in use would decrease, but size in bytes will keep growing. So you would need to run these cleanup cycles often. But also do note that in such conditions, your cluster, etcd cluster, will go into a read-only mode, or if I remember correctly, it would also not entertain reads in some conditions. So you have to take downtimes very seriously, and depending on how your Kubernetes clusters are being used. So this is very important when you are taking downtime for maintaining your large etcd clusters. Also, an important point is the 8 GB space quota limit. That is what is suggested by etcd right now, which is tested in all upstream conformance. Beyond it, it's really risky territory. I know many people have tried to do it and have had success, but they probably would have custom management processes which would manage that large etcd clusters. Next up, we saw a lot of network issues can hamper performance. Even before network, one of the important things is disk write latency. So etcd, because it keeps writing data to disk, it's highly susceptible to disk write latency. So what etcd suggests is you have disks which has minimum 50 sequential IOPS for typical operation, and for clusters running at scale, it should be minimum 500 sequential IOPS. Do note, whenever you provision VMs in most providers, the IOPS rating which is given is concurrent IOPS. So you have to think about sequential IOPS as well when deciding on what disk you want to store your etcd data in. Suggested is like you can use like local NVMe disks or local disks which have high throughput to store the etcd data. Next up is network itself. So when you have like multi-member clusters, if you don't have adequate networking performance, you might run into cluster partitions. Like members might partition, and they would go out of sync. The project suggests like having a 1 gigabit throughput for like typical operations and 10 gigabits for like high scale operations, so that the mean time to catch up for followers is low, and followers can catch up to leaders as soon as possible. Now people running Kubernetes will find this useful, and which is like mostly like I think 99% of the people that raise their hands. So some Kubernetes objects are like high churn objects. They're really high volume. For example, events or things like leases. So depending on the reliability or the amount of churn that you expect for each Kubernetes resource, what you can do is you can use the etcd server's override flag in kube API server to essentially tell API server to maintain the other resource types or specific resource types into specific etcd clusters, and all of the other objects will go into whatever etcd endpoint that you define. The other thing is avoiding too many expensive queries. So we all probably, so whoever is running like Kubernetes clusters at high scale would have run into issues someday with large list calls. The problem with list calls has largely been mitigated in Kubernetes since Kubernetes 1.33 with streaming encoding of responses. But etcd still faces memory spikes, resulting in like kills of etcd clusters, and it's a very challenging problem to solve. So the project is working on introducing something called stream ranges. So stream range queries will essentially reduce consumption for large queries. Currently, this is on the etcd 3.7 roadmap, but my conversation with maintainers, they still need people who can work on it, people who can devote time to essentially test this feature, work on POCs to figure out like how to solve this. Having said that, these are just a few of the operational things, like the top concerns that you would run into when running etcd at scale. There is a very detailed data operations guide on the etcd documentation itself, and largely of what we talked about here is from the operational guide. So it is highly recommended that you all go through the operational guide. I know like we as Kubernetes consumers might sometimes like not go through the etcd op guide, but it's a very good resource to go through. Having said that, if you want to learn more about etcd, which I think is obviously you would know about the etcd website by now, but if you want to connect with the maintainers, if you want to connect with people using etcd, join the SIG etcd Slack channel on Kubernetes Slack and do ask questions. And we talked about etcd diagnosis. So you can check out the repo at github.com/vmware/etcd diagnosis. There is going to be a demo booth session as well in the project pavilion or in the sponsor booth station area, where we'll talk about etcd diagnosis and what it can give you. With that, I thank you all to join this talk. We're open for questions. Put the mic.
Can you all hear me? All right. One of the, not really a question, more of an observation. As a Red Hat technical account manager, I've looked at probably 10 to 15,000 clusters. And the biggest caveat that I see is you want to be looking at leader changes. A lot of customers don't even realize that your etcd pods are losing leaders. You should not have a leader change if the pod isn't restarting. So look at your Prometheus metrics for etcd leader changes. You want to look at took too long errors. You want to look at slow apply and slow read index. It's your number one, sorry, it's your number one indication that your cluster is running slow. Now, it's normal. etcd is not perfect. It's a slow database. Half the time, you don't even realize it, right? You deploy 50 pods, 1,000 pods, you're pulling a 1 megabyte config map, etcd is going to be slow. Can't do anything about that, right? But if you're looking for your slow applies, it lets you know etcd is going beyond that 200 millisecond took too long time limit. And every time you see that, you're going to see a metrics inside of Prometheus. The best part is, if you look at the graph and it looks like a sawtooth, that means your pod is restarting and your counter is resetting. etcd should not restart. Last but not least, heartbeat. Looked at the metrics for failure to send out heartbeat. That means your etcd pod is taking too long to complete that request. Failed heartbeats means leader elections, right? If I'm sitting here and I'm talking to this gentleman and I'm talking to this gentleman, and that guy disappears and comes back 5 minutes later, your etcd is unhealthy. 99% of OpenShift customers don't even know this is happening, and they're opening tickets because they're getting IO timeout errors, they're getting all these Go-laying errors, not realizing that your API is taking too long because your etcd is taking too long. So look at your slow applies, your slow read index, your leader changes, and your heartbeat failures. Those are your 4 Prometheus metrics. They're going to tell you your etcd is too slow, and then you got to either figure out, do I need more memory, more CPU, faster disk, faster network? But those are your 4 indications that etcd is your problem. Great talk, guys.
Thank you for the great operational advice.
Hi, can you hear me? Yes. So I noticed that you guys created a separate etcd cluster. Sounds like an events cluster. I was wondering what led to that decision instead of increasing the size past 8 gigabytes.
Can you repeat the second part?
Yeah, so you created an events cluster, right? So you have 2 separate etcd clusters. Why create a separate events cluster instead of going past the 8 gigabyte limit?
Yeah. So you might need like different characteristics for different resources. So you might need some resources to come up like really fast. Think of it as like heterogeneous kind of resources. You might want like different performance or different like object count limits for different kind of objects. Like you might want to support like 10,000 config maps in a far higher SLO than like events. Events might not be as important for your clusters. That's why you think about like if you want like different server overrides for specific objects.
Well, wouldn't both etcd clusters be expected to be just as performant as each other? Or what makes them different?
Events are high churn, high volume. Deployments, pods, stateful sets, they might not be that high volume.
Got it. And then lastly, so what drove that decision for you to create a separate events cluster? Was it performance? Was it latency? What was the actual catalyst that drove you guys to make that decision?
I think that is like just a decision based on like what your performance requirements are for your cluster. There is like we don't do it like specifically. Are you asking us as like community members
in your organization? Like what drove that decision?
So what we ship is customers, they can decide like however they want to run.
Okay. Thank you.
Can you hear me? Yeah. I'm not that familiar with etcd, but I was wondering, were there any pitfalls that you ran into involving security? I don't know, maybe something to do with PKI or RBAC or anything along those those kind of issues. So anything specific to security?
So security, PKI, and all of those would mostly be relevant for Kubernetes. For etcd, like think of it as just a data store. So all you need is like etcd cert rotation. Those kind of issues might occur, but we did not mention them in our talk.
So you're not doing any authentication to the database or anything like that? Or?
etcd, you just authenticate using the certificates itself. But I think what you're talking about is the Kubernetes authentication, if I'm right?
Yeah, I'm sort of thinking in terms of integrating with Kubernetes and And
Yeah,
I'm just curious if there were any pitfalls you ran into from a security perspective. Yeah.
So clarification, we wanted to talk about like etcd pitfalls resulting out of Kubernetes operations, not specifically Kubernetes pitfalls.
Okay. I mean, yeah, I was just curious. Thank you.
Thanks.
Sorry, I wanted to jump in and answer that question really quick about a secondary etcd database. Give you a real use case scenario. We have a customer that runs scheduled jobs every 2 hours, and it generates 60,000 events in about 20 minutes. That will kill your etcd cluster. But if you have a secondary etcd cluster configured on a separate master node, on a separate faster NVMe disk, okay, real quick, the 60,000 etcd cluster is not going to affect the rest of your cluster. So you write all those events to an etcd cluster, they get killed by the TTL on events, and then that way it doesn't affect the rest of your cluster. Your cluster continues to be performant. That's the reason why you would have a secondary cluster if needed.
So you guys mentioned that to have good performance, you have 50 to 500 IOPS, sequential IOPS on the disk or something like that. So can you be more specific on like what do you mean by an IOP here? Like is it like block sizes? Like is the disk should specify what is this block size and these many IOPS?
I'm not able to hear it clearly. Can you speak up a little bit?
Oh, really? I thought I was speaking loud. Okay, anyway. So my question was like, is better now?
Yeah.
Yeah. So my question was about the performance characteristics. You guys mentioned like your disk should have like 50 to 500 sequential IOPS for the better. So it wasn't not clear to me like what do you mean by an IOP here, right? Is it like what is the block size? Who is doing that IOP? Like is etcd writing at certain block sizes, or is the physical disk should support this? It's not clear to me, so just trying to understand.
It's a disk. The disk should have enough capacity to have the 500 IOPS.
Capacity probably doesn't have to do with IOPS, right? So I'm just asking, like you said, sequential 50 to sequential 500, right, for better performance. So I'm just asking, does the disk block size matters here? Or what is the block size for an IOP? IOP has to be defined by a size, right? I'm just trying to understand the block size requirements here.
I'm not exactly getting the question here. Like,
Okay, no problem. Yep, we good.
Hi there. I'm curious if you have any particular thoughts or recommendations for people who have like a large number of watches that they're trying to do on etcd. What are the scalability concerns? What are suggestions, etc.?
For like large, like this is basically the large cluster problem. What you were asking?
Well, specifically like with regards to subscriptions, if there's something with like trying to have like a large number of people watching data in etcd, if you have any specific thoughts or recommendations there, or not.
Okay. Yeah.
Yeah. So when you have like large data sizes, what you might run into is like, let's say if you're even doing like smaller list calls, but you have like really large config maps, let's say, that might be an use case or a problem that you might run into. The blocks that would be stored on etcd, they would be like contagious in a way. So when you do like compaction and defrag, there would be like more operations to even like move things around. There might be like, okay, you might have like 10 MB objects, but there might be like very small space in between. So the compaction operation and the defrag operation might itself like take a little bit more time. So I think those considerations need to come into the picture. But in terms of like network payload over the network, the total size matters more in that case.
Thank you.
We can take more questions offline. We will be here in the hallway. Thank you all for attending.